Hello and welcome back. My name is Corey, and I guess you're my rubber ducks for the evening. And this is the series of episodes where we are creating Tang, a custom programming language from scratch. We're creating the programming language itself using nothing but our C++ abilities and a few tools such as Flex, Bison, Google Test, ICU for our string processing, Vim as our text editor, a terminal window to work in, and our wits. Yeah, there's no other way of saying it. Yeah, so this has been I'm trying to figure out if I was trying to say a program or a process or a project. It's something that's been going on for a while. We are on episode 71, and each episode we are adding features or refactoring to make things better. And we are pretty far along. And in fact, if I look at I normally say there's nothing up my sleeves. I haven't prepared anything ahead of time. If I say git log, the last commit that you saw was episode 70, the end of that. And if I say git status, nothing has changed. And if I look up, this is an include tang. Our to-do list. In fact, we can get rid of template scanning and short tags because we did that. And in fact, so I'm about to commit that change. But what are we going to tackle today? And I think we're going to do this one. Having a use syntax. Because basically I want to be able to have something like a math library. That I can say the absolute value of something, or the min of two values, or the max, or something like that. That's what I want to do. Yeah, that's what we're going to do. So, what did I just changed? Git diff. I just removed those. Okay. To do. Which is done. Fine. There we go. Okay. And we're going to start working on the use syntax. And, I always do this. Make clean and then get it started compiling on the right-hand side. And on the left-hand side, we're going to go back and let's see what we want to do. We want to have... we're going to start off with test.cpp. I know we're going to have to go into Flex. I know we're going to have to go into Bison. And I think we're going to have to add a new class. In fact, I already know it. So let me just open these. Let's go down to the bottom. We're at the bottom. And we'll say test library use. And what will this look like? Well, these are not going to be templates, by the way. So let's go up to where we had before we were doing templates. Yeah, compile script, that's fine. I want to go up a little further. There. And we lost our syntax highlighting. There. Now we have syntax highlighting back. If anybody knows why it's doing that, it seems to happen around the 2,000 line mark, and I just haven't looked to see if maybe that's a limitation. Maybe I need to break these up into smaller files. Could be. All right. let's see. So now we're going to say yeah. Just a simple use. And let's do this as use math. And what do I want to say? Math.abs of 3.5. Sure. And then this should print out a 3, right? That's what we think should happen. This is, of course, going to fail because we don't know what use is. So the only thing we need to add, I think, to flex is when we are parsing a script, and that's these. We've got all of our keywords, function, return break, continue, print, and I kind of want it, I think maybe after function. How about use? And you know what? I know that there's going to be another one that I'm going to do, and I'm going to have an as. And notice that we're not doing anything else. We're just the words use and the word as. Says I don't know what a make use is. That's because I haven't told Flex about it yet. So first, let's do where did I put it? Before function? Yeah, percent token use. What did I not like about that? Oh, we already have an as. Okay. I forgot that because we've got we're using it in our conversions, something as string. So we don't have to add that. That's fine. Oh, wait, then that means we don't need to put this as here because we already had one. Yeah, right there. I just hit save again, and okay, Flex compiled without any problems. Bison doesn't know what to do with the use and as because the problem is now we need an AST node that represents this use thing, and we're not even supporting the as yet, but yeah. Okay. So what we need to copy the include AST node, and which one do we want to copy for the we're going to call it a, AST node library. It's not really the same as an identifier. Is it an assignment? Assignment's going to be kind of weird. It's not a binary. It's not a block. We're going to do identifier. And this will be called include AST node library.hpp. And we need to do the same thing with our source, AST node identifier, source, AST node library.cpp. And we're also going to need a computed expression. Yeah. We're actually going to need two computed expressions. One of them, so which computed expression do we want to copy? This is like a really, really simple one. What's our simplest computed expression? An error? Maybe. Let's copy the error. And we will copy that to include computed expression library. Can't speak. .hpp. Oh. That was weird. And now copy our source for computed expression error to be source computed expression library.cpp. Let's edit our make file, and now we've got an AST node library and a computed expression library. So AST node library and library. Okay, and now this is going to be here to here plus 4, and we're going to substitute map for library. Okay. Now we've got computed expression library. All right. It's going to complain about double declaring stuff, but it always does that because we have to fix this stuff up. So we're going to do our source for, you know what? Where's our Vim? There we go. We're just going to add to this. So we've got our include for AST node library, our source for AST node library, our include for not AST computed expression library, and our source for computed expression library. Okay, should be everything. And now if we go to 4, we should be able to start substituting identifier for library and identifier for library. And I'm just going to repeat this in the next thing. Okay, this has a lot more in it than I thought, but that's fine. Oh no, we copied error. Error. So errors are a lot more complicated than I remembered. There we go. Okay. So what's this going to look like? Well, we are going to need a name of the identifier, and we're going to have an alias. All right? Do I want to do it like that? Okay, so just had a quick think, and we will say the alias to use for the library expression. See if we can work with this for right now. And name, okay, that's fine. But then it's like, well, what do I mean by library expression? So this is going to be library expression. And it's going to be a shared pointer to an AST node called expression. And we're going to need library expression. Okay, that's fine. compile and compile preprocess. I think we can do this. So I've got name and expression. All right. So AST node library, and now we've got a shared pointer to an AST node, and we're calling ampersand expression and a name. We're saving expression and name. For now, I'll leave the dump as that. Compile preprocess. Oh, so I've got this weird thing of add library. That, I mean, because before it was add, well, whatever this was, identifier, I guess. I think that these should still be identifier. Because we're just trying to say, hey, we're going to use this, and name is an alias. But if I say, that's probably going to be on a later episode. I was going to say, if I say use math, should not be able to use that inside of a function, just like I can do that with my function declarations. So I'll think about that. What does the compile look like? Get libraries, maybe. We don't have a program.get libraries, but we're probably about to. No, this was not libraries. This was get identifiers. Now this is right. This is for when we're putting it on the stack or referencing it elsewhere, right? Yeah. So we're using identifiers because that keeps track of where it is on the stack, and we do want it on the stack. It needs to be on the stack. Oh, it doesn't like expression being where I have it. So let's do this. That gets me through. On to the next. So this is a computed expression library. We'll do the dump, make copy. Is equal, do I? I think I'm just getting rid of all of those. Oh, this was the error object. But there does seem to be something private here. The question is what? By the way, nope, computed expression and macros, because I think we're about to need it. So what is this going to be? What in essence will a library have? Let's open our include macros. And we've got a native function, which is something that takes a vector of garbage collected, and these are things that it's meant to be called. Okay. A native bound function, which takes a this and then a list of args. A native bound function map, which is strings to native bound functions. And then we've got context data. I'm thinking we need a map of strings to well, isn't that a native bound function? To native functions. Yes. That's what we need. A map of native function map But is this also right? Yeah. Yeah, we can do this. So we've got this idea of a native function map. And my computed expression library now is what did I just call that? Native function map. I'm wondering if I'm painting myself into a corner with my approach here. But I think you know what, let's just build it and see what happens. Reference to the reference to the native function map. Provided? Is that right? This library represents. Sure. And notice it's a pointer. I know it is. But this should be safe the way we're using it. And what do we need? We need pointer. We will call that library. Okay. That should be fine. See if it complains. Just the fact that well, that didn't work. Dump is going to be library, and this I don't have a name to give it. All right. Library. Oh, it doesn't have one named library. Maybe we should call it library. Okay. We're at a stable point. We're not doing anything. We're at a stable point. So, I think I want to say git status and just kind of make a commit at this point. Even though it's not stable, well, it's not passing all the tests, but there. All right. Now we can get back into this. And what does this look like? So if we go back to our AST.node library.hpp, we will have an expression and a name. An expression and a name. So if we go back to Bison, where's map? AST node library. Okay, and what we've got is, so this will be a I don't want it to be something that's in an if. Although, should it be allowed? I don't think it should be, but maybe it should be allowed. Let's try it for the moment. Let's do this. Let's say use identifier semicolon. Okay, that is our very first one that we have. Node library, and this is going to be, what does the library need? It needs the expression followed by the string followed by where it is at 1. So what is the expression? The expression is, why am I calling it an expression? Because I know I just kind of stopped talking. It's almost like it's loading a value, but it's doing it in a special way. And what do I use for an identifier right now? AST node identifier. I'm okay with that. $2. That was evidently a split command that I don't know how it works. $2, and its location at 2. Well, enough, that would probably be correct. What did I miss is the... So the AST node ranged 4 doesn't complain again about this construction. So let's look at the include for AST node ranged 4 and see how it's shared pointer to the target. Shared pointer. Oh wait. To an AST node identifier. Yeah, I'll do that. Ooh, wait. It shouldn't be, it should be an expression. Okay. So my problem is that ampersand, I think. And now we'll see where it gives me errors. It may be in the same place. Yeah, in general, I'm just using AST nodes. I don't want to fight with this all day, so I'll just say auto equals there. And I'm just probably overlooking something, but like I said, a lot of times it's the end of the day for me, so I'm kind of tired. And so now we're giving an identifier, but that has its own name, the identifier, as the alias. At least that's the hope. Yep, I see my error now. I have done this more than once. That's what I needed. Why it didn't come out as a syntax error first, I don't know. Maybe it did and I just overlooked it. That was a waste of 10 minutes. Okay, so now we've got this AST node. And the AST node library.cpp, if we go there, and the dump, what would this be? There, that should work. Oh, using the wrong name, but that's okay. Oh yeah, it's expression. This arrow. That's fine. All right. So for the pre-process, the name is the alias, but we also need to call not indent. I don't know if this is right or not. What do I want to do? Do I actually need to add a string that represents anything here? I don't think so. I think they're all seen as identifiers. Oh, but we do use those for strings. So what does I'm going to edit the source for AST node identifier. In the preprocess, we add identifier of the name, and then we say it's assigned if it's assigned. This is unfortunately turning into something a lot more involved than I was thinking of originally. The problem is that if I say math, and if I later use a variable called math, but math as m maybe, m is the variable that I want to track. Math just is something that gets passed into my, hey, give me this library name, but nothing else in our program. In fact, maybe if I edit the source for AST node not source, the include, for AST node identifier, its name is public. So I can just get to the name. Okay. And if I say program add identifier, not identifier, it's a string. So I'm just cleaning up some stuff so that I can get here. I know I'm going to be calling a function on this, and so I know that this is ugly, but that's just so that I know where I am. I need to edit the AST_node string, it has a compile literal and is there we go, compile literal. What I need to know is who calls compile literal. Oh, I'm checking if it's an identifier. That's fine. Nope, I'm putting that in the wrong place. Why do I have literal? Because I said the word literal. Identifier. The problem is I'm trying to hold the entire thing in my head, and when you're tired, that gets difficult. And so I was looking at compile literal. Who calls compile literal? There we go. The function declaration. Compile literal is not a virtual function. So it exists specifically for a string, and I'm using it specifically for a function. Okay, so let's look at the function declaration. When I'm compiling it, it's on line 89, so okay, I missed it. This is going to get messy because this is what happens when we're compiling a function declaration. We have to get all the strings. So the only reason we're calling in line 89, it's because we're basically repeating what happens for a program itself. So if we also edit source for program.cpp, and go to line 126, reserve space on the stack for each string. Okay, so this has been pushed into something called string literals. So, go back to my documentation, and in the program object, crazy though it be, I have add identifiers, add identifier, get identifiers, add identifier assigned, get identifier string, add string. I think that we should add the identifier as a string. And when we compile it, yeah, now that I'm looking at it, I think that's the right thing. So I think we're at 5. So we add an identifier for the alias. And now we need to program dot add string, and that's the name. Now to compile it, we're not doing it this way. Let's look and see how the string compiles. So we're on 5. How does a string compile? There. Oh, so we've got to do the is trusted, is not trusted. Add string, yeah, and a Boolean is trusted, true. We'll just say true. All right, now for the compile, we're going to go back to, because I wasn't paying close enough attention, to the string compile. And we're just going to yank its contents and go back here for the moment. There. So the strings are the program gets strings, and we're going to make sure that the strings count of do that again. This won't work for multiple levels. Well, we can say okay. So if I've got an identifier, then grab its name, and what do I do with that? So what I'm saying is, so if the expression is an identifier, that's the only case we're writing for right now. If it's not an identifier, just return a null. If it is an identifier, then get the name of the identifier. And find it using a true. Name and true. A peek. name true. We're adding the bytecode to say, okay, peek, and then now we need to add program, add bytecode, library, and that is do a library call. What is library? We haven't written it yet. Either way, so what will library do? Well, or what is the point of this? Math will be a string, and then we load that string, we peek, and the location of the string, so that will now be at the top of the stack, and then we call library on it. That's not quite right, though. Well, we call library, and that should, yes, we're right. So edit the include opcode, and now we need a library. Print, and I was putting it before map, but let's put it after map here. So we're going to pop name push library with identified by name. That should be fine. I already know over here, because I changed the opcodes. Now we need to edit the source for program dump. And so where is function going to go? No, not function, library. It's going to go right after map. Right after map is library. And I don't think library, yeah. There. It's just a one opcode thing. Alright. Edit source for program execute. Opcode map. It's going to go after that. Now we're going to get into stuff that we haven't written yet. Case opcode library. We don't need execute program check, but we do need a stack check of 1. And then what do we do after that? Okay. From Tang. And push it onto the stack. So what do I do when I have, so 256, oh, I can remember that number. When I have the period. Right hand side, the left hand side, I call the dunder period, and if it is a, I go ahead and, if it's a native bound function, I set the target. Okay. And I just push back the result from the dunder period. And that's going to be on the source for any computed expression, the dunder period. And what we do is we get we call Tang get object methods, and I think we're going to have a Tang library, get library methods. Yep. Ah. There. If the name is a computed expression string, which it should be, then do that. Otherwise, so we've got to do that, of course. This should probably be in an else. So what I'm doing at the moment is this error isn't quite right. It's saying member is not found, but it's that's not the best error message. It's more of unrecognized operand. On library opcode. There. There. We can't use this computed expression to access a library. Now, so if our name is a computer expression string, then we're going to so if we say get libraries, we don't need the this type because we have name. So instead of object methods, substitute object methods for libraries. Do the same thing, but substitute this type for name. Wait. Methods is equal to libraries at name, and then all that we need to do is stack dot push back garbage collected make what did I call that? Because it's a native function map, so you make a native function, and what do we need to give that when we create a native function? No, it's not a native function. I mean, sorry. Computed expression library. And what do we need to add to that? So we should have a computed expression library.h. That's buffer 6, and then we'll come back to 17. What does it need? It needs the native function map, a pointer to it. We can do that. Oh, 17. All that it needs is methods. And is that it? Can this be as simple as push back otherwise? Oh, not stack.pushback, but garbage collected make, or that. So I either push back. So if it exists, then, well, push the computer expression library in. Otherwise, this should be a different error. Unknown library. And that should be fine. Oh, I was expecting this to compile, and, well. Now our program have a million errors, compile errors. It'll take me an hour to track them all down. So I normally have it compiling during this time. Opcode.hpp, really? Somehow didn't put a comma after library. Oh, well, we didn't add the whole get libraries thing to programs, so I think we're about to have to edit that. Our include for program.hpp and our source for program.cpp. And oh, so that's 14, and then 19 is .hpp. And oh, there's other problems. It doesn't like in program execute. I evidently forgot a closing bracket or something in the execute, so that's 17. There. Yep, get libraries does not exist. Okay. So where are all the gets? Get strings. A lot of target stuff. Easier if I do this. So I think this is, oh, I'm looking in program. This is not in program. Am I in program? I am in program.hpp. This is not on the program. This is on the Tang base. Get object methods? Yeah. Source, edit the include for Tang base. So get the object methods, and now we've got store available object methods. Am I using macros? There. Now I'm on number 21. Where's macros? Have not opened it in this thing. Okay. The reason I'm asking is because this whole map of a string of blah blah blah, map of string of pair of native bound function is native bound function map. String of size C of native bound function, all of this should be native bound function map. Should be. And now we need one for store the available libraries. And it will be a map of wait. Where's macros? Is that right? A map of native functions? Is it just a native function map? Something tells me that it needs to be more than that, but yeah, this is a map of strings. Oops. There we go, get libraries. And this, I also should all right, so now I've got this Tang base.cpp. Give it a default constructor. And now, just moving that off the screen where it will now be in the way of my other screens. We need to go back to the program execute, because we're calling that on, oh no, Tang get libraries. We're giving it the name. Okay. So, what do we not like? Probably a lot of stuff. Program execute. 260. That's right here. An ordered map doesn't have a count. I think I've learned something. If you search for C++ map, you get all sorts of junk. If you search for unordered map, you get the reference. It seems to me like it has it, so maybe I didn't read enough of the error message. Oh, I'm giving it a garbage collected? It is a computed expression string. Is equal to static cast as a computed expression string ampersand of star name. And computed expression string, can I get to the value of it? Do I have to call dump? Maybe? Oh, of course, that needs to be a period. Library. Your expression library was not. Okay, we're back to no test passing, but we've got some stuff in place now. All right, so I'm wondering if I need to, at this point, pause and, just call this. And I know that not all of our tests are passing. Um, but what needs to happen? Well, basically, so we've got this idea of a computed expression library. And now we want each type in the... So when I say math, that should be a library type. So computed expression library math, which means I need to create another object. But that way we can then use the sorry, what I was thinking about was the fact that we could then use our current system for how we add, like, the length to the string, to add the parts to library. But the question is, can we do that? Should have thought through that a little more, shouldn't I have? Ultimately, we want if I were, for example, to say math.abs as abs, then I would want abs to represent the native function abs. So that means math.abs should reference the computed function, which means it would work just like the current period operator. Yeah. All right, so here's what we're going to do. We're back to our test cases, and here's what I'm going to, for the moment, comment out the test case, because we're not to the point where it's running anyway. And so that means we've added stuff, but we're not to a steady state where we can test the functionality. But I will go ahead and add what I expect. So use math as m and say m.abs. Or how about use math.abs as abs. I mean, these are the forms that I'm wanting to get to. And we're going to have to do some more work. And that's why I think it's worth my time now, at least mentally, right, to stop and say we're at least to a place where Code is compiling. We've got stuff, even if it's not functional, everything else is still working. And now, see, we've made a lot of change. That's why I was like, let's pull the brakes here a little bit. So what did we do? We've got our AST node library. We have the use identifier. Added our opcode. Got our macros. What is this file in? AST node library. Got a better dump, even though we're not. Well, we'll see it in action in a little bit. It looks very Christmassy. All the red and green. It's almost Christmas here when I'm recording this. Okay, that's fine. We've got our code to load it, and we're only doing it for, so when we get to the math.abs as something, we'll need to do some extra work. But for right now, we don't have a way of creating the libraries yet. I said the word, but my accent makes it sound like I didn't get all the word out. Sounds like library or something. Library. Anyway, we've got our unordered map, blah, 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 and our tests that we are commenting out for the moment. Good place to stop. And the last thing, first step of library functions. So git commit -am, and we're going to say, what have we done? Second step, add use keyword and prepare for library objects on the Tang base class. I think that's good. And now let's just update our docs. We'll push that. And while that's loading, what episode are we on? Episode 71. Alrighty. So I didn't mean get diff. Is there a lot? Yep. Episode 71. Must be a lot that changed. All right. Episode 71. All right. So we're there, and just kind of a check. We might, by the time we're done with this simple library stuff, which by the way is huge, we may hit the 10,000 mark for our code. I can really see that, especially with the tests, but or even just a basic math. If I do an absolute value and maybe a min and a max, or a round, just simple things, even a handful, I think it's enough to push us over the edge because we're really close. And but with that, we are at a good stopping place. Everything is pushed, and I'll come back the next time, and we will continue on this, and we'll be looking at, okay, what does it really mean when we say use math? That should return an object, a computed expression library, and then that computed expression library should, when then I say .abs, it should have a dunder period. It should implement that and say, and it should have its own source of, in fact. That's what it is. That's how we structure this. So math will result in a computed expression being returned, and then the dots are just going to be period operators on that, and they themselves could either return another library, or they could return it's something that's a computed expression, right? So it could be a string, it could be a function. There's a lot of things. Yeah. And that would allow us to be able to say, request.user or request.time, and it not be a function that it's returning, but maybe a time object, or maybe a random number generator. So or probably not math. I'd probably have us dedicated, but random.seed, and it return a value, or excuse me, I like the idea of having multiple random number generators, but that's an entirely different thing. Yeah, there's a lot of things we could do here. So that's a good place to stop. Okay, I'm having too much fun thinking about now all of the possibilities of what we can do. And as always, thank you for joining me. I know that this one was probably a little underwhelming, even though we got a lot of work done. It doesn't feel like it because the new functionality isn't there yet. But the truth is the new functionality is huge, and it just requires a lot of plumbing in place to get it to work and set up right. And the point is, it's going to be working in the context of all the other stuff that's working great. And so, yeah, that's what we're looking forward to. All right, once again, thank you. Hope you have a great day. And depending on when you watch this, well, anytime, Merry Christmas. Even though it's may not be Christmas when you're watching it. Have a Merry Christmas anyway.